Hi students, I am Ramakrishna. I am teaching you the physics. So today I am going to do my first video. So actually I have chosen the very interesting topic which is very helpful for physics, that is the vectors. In another way, simply to say, I am going to teach you the basic mathematics for physics. Okay, so that one of the most important concept what we are using in physics is the vectors. So how these vectors concept of mathematics is going to be used in physics, that you will come to know today. And what is the basic idea in giving the vectors? So let us see that. So vectors. Generally, why we need the vectors concept in explaining the physics? Okay, suppose you think about a few physical quantities. You tell me that displacement, velocity, acceleration, mass. Okay, like these, if you take velocity and before that displacement and acceleration, mass, time. So these are the very important physical quantities what we discuss in physics. But if you look at them carefully, you can classify them into two sectors. So what are those two classifications? One is, see here, from here to here you can say that these are vectors, these are scalars. Why we are saying these are the vectors, those are the scalars? So if someone asks you what is the time now, what do you say? In a north 3 hours, in south 4 hours, like that will you say? No. We don't need any direction to understand the time. Wherever you may be, just you say, okay, it's a 3:30 or 3 o'clock, 4 o'clock, just you say it. Okay, but when it is in the case of velocity, you need to mention the direction of the velocity to understand correctly. So that is why we need at least two details, magnitude and direction, and as well as it needs to satisfy addition law of vectors. So these also have to satisfy to call them vector quantities. So these are vector quantities, these are scalar quantities. Okay, whenever we are giving the vector quantities, it needs to mention, already we have previously told, at least two details, magnitude and direction. So how it can be represented? And not only that, you can talk about motion. I mean, that is a displacement. Suppose let us talk about an ant. ఒక చీమ గురించి మాట్లాడదాం. ఒక చీమ ఒక ప్లేన్ మీద వెళ్తుంది, నాట్ ఏరోప్లేన్, సర్ఫేస్ ప్లేన్ మీద వాక్ చేస్తూ ఉంది. నౌ how this ant is moving? Okay, is it moving in x direction or y direction, z direction? How it is moving? We need to give the details. Okay, so take this. If an ant is moving, see that in a coordinate system you can say it is x direction, x dash, y dash, okay, z dash. So these are the directions. ఈ చీమ ఒక బాక్స్ మీద ఉంది అనుకుందాం, ఒక క్యూబిక్ బాక్స్ తీసుకొని బాక్స్ మీద వెళ్తుంది. ఆ బాక్స్ మీద ఎలా వెళ్తుందంటే, ఆ బాక్స్కి మనం కోఆర్డినేట్ సిస్టమ్ ఫిక్స్ చేసాం. ఇఫ్ ఇట్ ఈస్ మూవింగ్ ఇన్ ఎక్స్ డైరెక్షన్, ఓకే, యాంట్ ఈజ్ మూవింగ్ లైక్ ఇట్స్ ఎలాగైనా మూవ్ అవ్వచ్చు అది, కానీ ఎలా మూవ్ అవుతుందని ఇప్పుడు చెప్పాలి మనం, వేరే వాళ్ళకి అర్థం అది చెప్పాలి. సో దెన్ హౌ కెన్ వీ టేక్ ఇట్? If it is moving in x direction, we are going to give that with the I cap. If it is moving in a negative x, mean opposite to the x direction lo ant move avutundi. Now it is moving in this direction, then what you will give? Minus I cap opposite to that I cap. Minus means opposite to that. Now let's go to the y. If it is moving in a y direction, you are going to give it j cap. If it is going down, then what you are going to take? Minus j cap. Minus j cap. If it is moving in a z direction, what you are going to take? It is going to give k cap. And if it is moving in a z dash direction, you are going to take it as minus k cap. Minus k cap. ఓకే, సపోజ్ ఇక్కడ మీకు ఒక క్లారిటీ ఏముండాలి అంటే అండ్ సపోజ్ ఎక్స్క్యూజ్ మీ, ఈ పెన్ మీద ట్రావెల్ అవుతుంది అనుకోండి, పెన్ మీద వాక్ చేస్తుంది. ఐదర్ మూవ్ అయితే ఫార్వర్డ్ అన్న మూవ్ అవుతుంది, లేదా బ్యాక్వర్డ్ అన్న వచ్చేస్తుంది, అంతే. ఇక ఒక ప్లేన్ మాదిరి, ఒక సర్ఫేస్ మాదిరి, ఒక ప్యాడ్ మీద, ఒక బుక్ మీద ట్రావెల్ అవుతున్నట్టు వెళ్ళే ఛాన్సే లేదు. ఇలాంటప్పుడు వెక్టార్స్లో మనం ఏం రిప్రజెంట్ చేస్తాము అంటే దట్ ఈస్ గోయింగ్ టు బి ఇండికేట్ విత్ ద వన్ డైమెన్షనల్ వెక్టార్, 1D వెక్టార్. 1D వెక్టార్. నా ఒక ప్లేన్ మీద, ఒక బుక్ మీద యాంట్ వెళ్తుంది. సో ఇట్ కెన్ కవర్ ఇన్ x direction or y direction or diagonal it can go. Then what you can say? You can say that it is going to be the 2D vector. It is going to be represent or give the answer with the 2D vector. And third one is going to be, suppose ఇప్పుడు దీనికి ఒక ఎగ్జాంపుల్ ఏం చెప్తామంటే, ఒక కంటైనర్లో లేదా ఒక బాక్స్లో ఒక దోమను వదిలామనుకోండి, మస్కిటో. సో హౌ ఇట్ ట్రావెల్స్? విల్ ఇట్ ఫాలో 1 dimension, 2 dimension or any? No. However it wants to go, it can go. But if you want give that information, that you can give by the 3D vector. So how we represent that vector? See, in 1 dimension, suppose I am taking x I cap, and in 2D vector x I cap plus y j cap. Next 3 dimension x I cap plus y j cap plus z k cap. I am going to get it. So if it is moving in a 1 dimension, on a wire, on a pen, on a scale length, so if it is moving, we are going to take in a 1 dimension. So that can be xi or yj or zk, any of these, or minus also, minus of them, respective of them also you can take it. But when it comes to this also you can take any, but it should be 2 dimensions. What are those? X and y. Now if it comes to the box, like we have discussed mosquito. Okay, ఒక మస్కిటో ఎలా ఒక బాక్స్లో ట్రావెల్ అవుతుంది. సో దాన్ని డిస్క్రైబ్ చేయడానికి మనం xi plus yj plus zk cap we are going to give it. So whenever, what is the meaning of this? I want to give the description and meaning of this. What is the meaning of writing x I cap? Okay, in what is going to be x, what is going to be I? X is giving us magnitude. I is going to give us the direction. The next of the magnitude, whatever is there, that is going to give us the direction. So if we want to understand that, right? So ఇప్పుడు నేను ఒక చిన్న example is, I think you will understand it. I am giving the small example. minus 4j cap meter per second. If I give it meter per second, just by looking at the unit you can understand that is the velocity, right? And what you can understand, in which direction it is moving with that velocity. Can you give? See it, minus j. So what is the first value gives us? Magnitude. What is the magnitude? 4. What is the direction? J. So that is minus is also there, minus j. Okay, means in y downward, in y downward, something, whatever that may be, ant or mosquito, bus, car, whatever you take, just that object is moving downward. Now can you tell me what is the magnitude of it? Magnitude is 4. What is the direction? Minus j. With that you can get it, right? So if it is a one dimensional, okay, easy, quite easy, you can say it. If it is a two dimensional, if it comes to the two dimensional, how can you say, how can you identify the magnitude of it? Suppose 3 cap plus 4 cap meter per second is there, meter per second is there. This is the two dimensional. Now what is the magnitude? Can you tell me what is the magnitude of it? Oh, it's a, we have two quantities, how can we get? Okay, then if it is, if this vector what is represent is, take a bar equals to this. Now magnitude of a bar, modulus of a bar is going to be taken as square roots of the magnitudes, square root of the magnitudes. How it is going to take? Square root of 3 square plus 4 square. So that gives us the magnitude, that gives us a magnitude in two dimensions. Okay, that's why you should have the clarity. Now what it comes? 9 square root of 9 plus 16, that gives us square root of 25. Again what it comes? It is going to be 5 meter per second. 5 meter per second is going to be the magnitude of that vector representation. 3 cap plus 4 cap meter per second is gives us the velocity of 5 meter per second. Okay, we are saying 3 meter x direction, 4 meter y direction. What is the direction of this 5 meters? ఇక్కడ చెప్పినప్పుడు మనకు ఓకే క్లియర్ అర్థమైంది. 3 cap ఓకే ఎక్స్ డైరెక్షన్లో వెళ్ళింది, 4 ఓకే. అప్పుడు 5 మీటర్ పర్ సెకండ్ అనేది ఏ డైరెక్షన్లో ఉంది అనే ఒక డౌట్ వస్తుంది కదా. సో ఆ డౌట్ని క్లారిఫై చేయడానికి మనం ఒక పని చేస్తాం. సో లుక్ అట్ దిస్ 3i plus 4j. Where can I represent in the 2D plane? Okay, 2D vector. Where can I represent? Okay, we will see now. I will draw the diagram and again we will go to see that. So now we can see that the continuation of that. If let me take OA bar equals to 3i cap plus 4j cap, the magnitude we have get 5 meter per second, right? So then how we can understand what is the whatever the object is moving in it. So 3i cap, where is the 3i cap? We can take I cap is in x direction, right? 3 is this, magnitude is 3, I cap is in this direction. Okay, here is a point. Second one is what? 4j cap. Okay, j cap means in y direction. Okay, see these two where they can meet, these two 3 and 4 where they can meet, we have to take that point. That point, if a bar, that point a bar, this is the O origin. Okay, from here, this is from here to here, what is the 3 magnitude, what is the height? 4 magnitude. Directly join this, directly join this. What is going to be this? What is going to be this length? So take it, it seems to be like you can remember very easily. Okay, me coordinate geometry just so you can remember it. This is the 3, this is the 4. What is Pythagoras theory? If you apply it, you can get 3 square plus 4 square equals to, right, that whatever it is going to come like this. Now what is going to be the velocity? Just you are going to give the magnitude. What about direction? This gives us the value of magnitude. Okay, magnitude you got 5 meter per second, but what you need to have? You need to have the direction. You need to have the direction. Second information is also needed, right? What is that information? Where is this mean in which direction it is moving. See, in which direction it is moving resultant, okay, that is going to be given or represent with some angle with what it is moving. Here straight horizontal in x direction we have seen, straight vertical we have seen, right, in y direction. That's why we have given I cap j cap. But when it comes in a two dimensional, it is not in x only or not in y only, but it is covering both x and y. That's why it is going to be covered in like a diagonal sense. So that's why what we are going to take, theta is going to give us the direction instead of I, j or something. So what is going to be that theta? Now can we take it? So if it is a theta, what you can take it? Tan theta equals to what you are going to take? Opposite by, so adjacent, opposite by adjacent, 4 by 3 you can take. Theta is going to give us tan inverse of 4 by 3, tan inverse of 4 by 3. If you write tan inverse, what is going to be the 4 by 3 value? 4 by 3 value. So just I want to remind you very good logic and your competitive examinations, what can help you. Okay, so remember this, take here is a theta, okay, here is the theta. If in this case whatever the theta value gives us, the theta equals to tan theta, sin theta, cos theta and sin, cos, tan, 3 values you can take and substitute. If tan value, if you write it, some value will come here. What is that value? That has a very special importance. I will discuss you after this in a continuation. And now if you take tan inverse of tan of some theta, so tan of 4 by 3, tan of 4 by 3, okay, 4 by 3 gives us tan of some theta value. Either it is 37 or 53, that it gives us something. So tan and tan inverse will get cancelled. Theta is going to be that value whatever we get, either it is 37 or 53. What is going to be this? Why I am saying 37 or 53? Okay, instead of saying 30, 20 something number or 0, 30, 45, 60, 90, why I am saying it 37 or 53? I will give you the logic because it's a very important, and in most of the competitive examinations without giving any value, means a calculator, you can solve like these problems if it is having the 37 and 53 angles. Okay, that's why I will discuss specifically. I hope that you understand. 2 dimension లో ఉన్నప్పుడు 2D వెక్టార్ వచ్చినప్పుడు మ్యాగ్నిట్యూడ్ వచ్చేసింది, డైరెక్షన్ వచ్చిందా? ఓకే, డైరెక్షన్ కూడా వచ్చింది. We have given magnitude and direction, both values we have given, right? So that's why you need to understand how we have given, whenever the vector is mentioned, 2 details, both magnitude and direction we have given, you have to check it. Okay, so thank you. I hope that you understand these 2D vector, right? So when we use, what will be the practical application, you have to think. Now I am going to continue with this theta explanation. Okay, look at this diagram, you can easily remember this. Okay, tan 37, see this, or let us come from sin 37 value is how much? Sin 37, what is going to be sin value? Definition, opposite by hypotenuse. So what is going to be the opposite value to the 37? And just remember this, in this triangle how I have given opposite to 37, the first number is what? 3, right? 3 is there, so you remember like that, opposite to that 3, remaining just you can remember, because 3, 4 only gives us the result 5. That's why 4 should be another side, not hypotenuse. That's why you have to remember like this only, no other choice. Next 3, 4, 5. So opposite by hypotenuse. Opposite by hypotenuse. What is the value? 3 by 5. 3 by 5. Next, cos 37. Cos 37. What is that? Adjacent side by hypotenuse. What is the adjacent side to the 37? What is adjacent? 4. 4 by hypotenuse 5. 4 by 5. Next, tan 37. What is going to be the tan 37? So what you will write? Opposite by adjacent. Opposite side by adjacent side. Now with this, what you can write? 3 by 4. 3 by 4. Now you know that sum of the triangles, okay, sum of angles in the triangle is going to be 180. Now what you can understand, 37 plus 53 gives us a 90, and this is another 90, total 180. It's a fixed. Okay, in another sense, how you can write it with respect to the 53. Okay, try to understand this. Okay, if it is a 53, okay, here is a 53, and I can expect here is also 53, right? Here is also 53. Now with respect to 53, let me talk with respect to A, B, C. With respect to 53, if I take sin 53, sin 53 is what? Again, formula is same. Opposite side by hypotenuse. Opposite to the 53, because you are talking about 53, right? 53 opposite is what? AB. AB is a, now what is going to become? 4 by 5. 4 by 5. Common diagonal is 5. Next, cos 53. Cos 53 is going to be what? Adjacent side by hypotenuse. Adjacent side by hypotenuse. What is going to be the adjacent to the 53? It is going to be 3, right? 3 by 5. Now what is going to be the tan 53? Tan 53. Tan is going to be opposite by adjacent. So opposite is what? Opposite by adjacent side. That is going to be taken as 4 by 3. 4 by 3. So if you look at that, so I think you are getting some similarities, right? Some values are going to get equal. What are those equals? You try to understand. I will give the numbers to match. 1, 2, 3, 4, 5, 6. What numbers can match? You can see that. What numbers values? Sin 37 is 3 by 5. Again here cos 53. Okay. So what you can write here? What you can write here? Sin 37 equals to cos 53. Cos 53, that equals to 3 by 5. Now another match, can you try? Cos 37 equals to, what is another value? Sin 53. Sin 53, that equals how much? 4 by 5. Now what is going to be the another value? So that value is going to be here. Tan, in tan terms only it is there. Tan and cot in reverse, if you write, you will get it. So remember these values, because in many of the competitive examinations, without a calculator you can remember these values and you can do. Because if the resolution of force or resolution of velocity, if you want to do that, the angles are directly known, angle values you have known. If you substitute, easily you can get. Okay, so I hope that you understand one dimensional vector and two dimensional vector. In the next class, okay, in the next continuation, we will see this 3D vector. Okay, so I want to do more videos for you people. That's why I wish you to like and share and subscribe RK Factory Kurnool. Thank you.